So any object that is rotating in a circular or uniform circular motion or non-uniform circular motion, in whatever motion, let's say the body is rotating like this kind of zigzag motion, at any instant of time, this is the position vector of the body, and let's say this is another instant of time the body goes here, and at another instant of time the body goes here, and this is the Cartesian version, and this the rotation is happening, let's say in a 2D plane, and then there that r cap, theta cap, and here also this is the direction of r cap, theta cap, and here this is the direction of r cap, sorry, theta cap. So every time that r cap theta cap vector is changing, since their direction is changing, their magnitude is always infinity, but they are changing with respect to time, that r cap and theta cap vector, because their direction is changing. Here they are directed in this direction, here in this direction, that is the r cap, and theta cap here in this direction, here in this direction, and here in that direction. So this that's why the vectors are changing. So now our next goal is to calculate how that r cap vector is changing with respect to time, and how the theta cap vector is changing with respect to time. So what are these two terms in a zigzag motion, in any motion? So since r cap that we have already obtained is, sorry, let me change the color. So that r cap is nothing but cos theta x plus sin theta y, and theta cap is minus sin theta x plus cos theta y. So what is dr cap by dt? That is, sorry, so first I am taking the derivative with respect to theta, then d theta by dt x cap plus cos theta d theta by dt y cap. That is dr by dt is minus sin theta x cap plus cos theta y cap times theta dot, and theta dot is the short version of d theta by dt. So this is, and what is this? This is nothing but theta cap, that is theta dot theta cap. So dr by dt is nothing but theta dot theta cap. So now let us calculate what is d theta by dt. So that term is minus cos theta theta cap x plus, sorry, minus sin theta theta cap y. So that is minus cos theta x plus sin theta y theta cap theta dot. So that is d theta by dt is nothing but minus theta dot r cap. So we have following two relation, how the r cap and theta cap is changing with respect to time, that is dr by dt is theta dot theta cap, and d theta by dt is minus theta dot r cap. So these are the basic relation. So this is the basic relation. So now let's derive for any generalized motion like this kind of motion, that is this kind of motion. Let's say what is r, what is the velocity and acceleration, what is the expression for velocity and acceleration in terms of as a function of r theta, r dot theta dot, and their higher order derivative, let's say r double dot theta double dot, and of course in terms of the base vector r cap and theta cap. So now let's see how the acceleration, velocity and acceleration depends upon these terms. So this is the case of non-uniform circular motion. So this is the case for non-uniform circular motion. So let's start with the r vector. That r vector is nothing but r cap, where r is the mod of r. So this is r at an instant of time. Let's say the particle is here. So here r is r cap. So now in order to calculate the velocity, we need to take the time derivative of the radius vector. Now what is that? That is d by dt r cap, right? And since the radius vector is not constant, like here it is rt and the length of the radius vector is rt, so here is also the radius vector length is decreases and here it increases, and like the length is varying everywhere. It is different here, and everywhere it is varying. So that's why the dr by dt is not equal to 0. So the first term gives you dr by dt, then r cap, then the second term gives you dr cap by dt. That is r dot r cap plus what is dr cap by dt, that we have already derived, that is theta dot theta cap. So this is r like theta dot theta cap. So v is nothing but r dot r cap plus r theta dot theta cap. So how do we describe this two term? So this term is nothing but the radial term, because here this is the velocity along the radial direction, because r dot is here. So this is the radial part or the radial velocity, and this is the tangential part. So for a uniform circular motion, this goes away to 0 and this term was there. That was like our earlier cases. So now, since it is not non-uniform motion, so this term survives. So now what will be the acceleration? Acceleration is nothing but dv by dt. So that is d by dt r dot r cap plus d by dt r theta dot theta cap. So here, what is the first term? First term is nothing but r double dot r cap plus r dot r cap dot. Here we have there will be three terms, because there will be three derivative term. Because three terms are there. The first term is r dot theta cap. Second term is r theta double dot theta cap. The third term is r theta dot theta cap dot. So that is r double dot r cap plus r dot, what is r cap dot? That is nothing but r theta dot theta cap. Sorry, that is what is r cap dot? So it is dr by dt theta dot theta cap, right? So that is theta dot theta cap. And what is that? Is just r dot theta cap. What is this term? r theta double dot theta cap. But what is this term? This term is r theta dot, and what is theta dot theta cap dot? That is minus theta dot r cap, like this. So we are left with, so upon separating the r cap part and theta cap part, we'll get r double dot minus r theta dot square r cap, this and this, and then sorry, r theta double dot plus 2r dot theta cap. So that is our acceleration, this expression. So now let us discuss what are the parts. This, as the name suggests, we are taking the two-time derivative of r. So this is the radial acceleration. And what is this part? This r theta dot square, that is the centripetal acceleration, and that if the body is moving here like this direction, like this motion, it will act opposite to the radius vector. The radius vector acts along this direction. So this is the centripetal part, and that we have already discussed in our uniform circular case. And what about the third part? So the third part is the acceleration that comes if we from the changing of tangential speed, that r theta double dot, that comes from the changing of tangential speed. So since that is the r theta double dot, so that is the rough idea. And this part is a new term that is basically the fictitious force or that appears to act in a rotating coordinate system, that is known as the Coriolis Force, that you may ever may heard about. So in this force, about this we'll investigate a detailed study on this Coriolis Force in the upcoming chapters. But for now, this is just let's say this is just Coriolis Force. This is a fictitious force that appears on a rotating coordinate system. So these are the physical contribution. Now